Okay, welcome again to the AMD Technology Webinar. I'm your host, Kyle Damon. I have alongside with me Colin Lennox, CEO and MRU inventor, and also Brian Creer, our consulting engineer, to help answer any of your more technical questions. We'll get the questions here in about 20 minutes, but for now, what we want to do is introduce you to the MRU, or what stands for Metal Removal Unit, and we'll go into the details about how they work and how it could possibly benefit you here shortly. Colin, would you like to introduce yourself?
Thank you very much for coming on out today and joining us. My name is Colin Lennox. I'm the CEO of Eco Islands LLC, lead research and development and construction guy. Thank you.
And Brian, welcome to the call as well.
Good morning, everyone. Thank you for joining us.
All right, we are excited to introduce some ideas here to you and some facts and some new revelations that we've had recently about some new research. But first of all, we're going to keep this simple. We'll keep it short and to the point. We know your time is valuable. So, Colin, could you explain what exactly is an MRU, or metal removal unit?
A metal removal unit, then, is basically a wetland in a box. We've taken the ability of nature to naturally clean or naturally attenuate water and compressed it into a very small space. So we've got an ability to clean AMD water, iron, manganese, and aluminum primarily is what we're focused on right now, in a very compressed space for less cost.
So I know you've been busy with a lot of site visits lately. Can you tell me a little bit about what you've been busy doing and where you've been?
One of the things that we're most proud of is our most recent job. We've been working with Arch Coal and Vindex Energy as well as CEC to put in an 8-unit system in Maryland. And that system is used to do the final polishing for iron and manganese, which is becoming a big issue for everybody throughout the industry.
So I see that a lot, or I hear about that a lot. They already had a site in place that was a large, what would you call that kind of site that they had?
A big reclamation site.
Okay, and they were running out of space, but they still weren't meeting their TMDLs. Is that the situation?
Close to it at Island Seep. It was that Island Seep was a brand new construction. The other systems that we worked on, though, you hit a nail right on the head there, where they run out of space. There's a system that exists, and then the numbers get changed on them for your TMDLs on manganese, and they got to do something, and that's where we fill that role.
Okay, so you're helping to fill that gap between this ever-sliding number of what the TMDLs have to be year to year that they seem to change frequently?
Yes, yeah, that's exactly what we do.
Basically a never-ending battle.
Yeah. I mean, yes, you get cleaner water, sure, and everybody likes that, but the costs. When you have budgeted for one system and then the numbers shift on you, you have no choice. You've got to upgrade. Sometimes you don't have the room anymore, though.
Okay, so we'll get into the more specific numbers here shortly. Could you explain? Okay, we know it helps to remediate the water, but could you explain specifically who this is good for, these MRUs, and what type of sites these are good for?
Sure. The biggest issues that we've been coming across are, of course, the manganese issues for oxidation. Our systems will pull out all the iron that may be left in a system that's not working so well, and then we're going to pull out the manganese after that. Typically, how that's done currently is to use caustic soda or some other form of alkalinity amendment. Well, caustic, it's dangerous and it's expensive is the biggest thing. Our systems, because we preference what's called biofilm, we grow natural organisms just like a natural wetland. And because our reliance is on a natural system versus, say, a caustic system, our manganese can come out at a pH of 6.5 to 7, as opposed to having to run your caustic up to 7.5, 8, or higher. So in most sites, we're totally eliminating the use of caustic soda.
Okay, so you're seeing compounding savings over time.
Oh, absolutely.
Okay, I see. Okay, and tell me about the space, the footprint that they take up or don't take up.
Sure. Current systems can be, as those who are out there listening to us right now know, that some of these systems can be acres in size easily. Our systems, our metal removal units, are 4 foot by 8 foot by 4 foot boxes. Each one of them about 2.4 cubic meters of retention. Of total volume, which means they're very small in comparison. They're also modular. So kind of like Lego blocks, we can build together a system for treatment specifically tailored to what the how much more needs to come out of the existing system. So say you've got some iron, you've got some manganese at different rates. We would specify a system to make sure that we clean all the rest of that out to your TMDLs.
So each solution is customized per specific site? Is that the way I understand it?
Yes,
Okay.
yeah. And so we can just as easily be an add-on to a system that's not in compliance, and we don't take up anywhere near as much room to be able to meet those compliance standards. So we can shoehorn ourselves into a site that's already full.
Got it. Okay. So if you guys are watching the screen now, you'll see what we call our hypothetical site or our ideal site. Colin, could you walk us through this site a little bit?
Sure. What you're looking at is two individual seeps, then with an unspecific loadings of iron, aluminum, manganese coming out of the systems. Our systems and the metal removal units pull iron, aluminum, manganese in the sequence of I won't get into reduction oxidation, but once they have been captured, the material sequestered within the boxes, then we pump it out to a holding tank or holding ponds and go from there.
Okay. So here we'll show you the box next. Basically, these are the units that are in line in this previous photo. I'll switch back to so you can see over here on the left. These can be run in sequence or in parallel depending on your load rates and also depending on your flow rates. So depending on your needs, these boxes can be installed individually or in as many boxes as you need. Colin, do you have anything to add to that?
Modular, like Lego blocks said.
Okay.
Kyle, you nailed it.
Okay.
Yep.
And here's the idea of how Colin, you might explain this better than I can, how the water flows through the.
Sure. What we have here is you see some oxidative steps. That's one of the primary keys that allows us to make these systems so small. There is no wasted space. Within the system themselves, or within the box itself, as you can see, there's individual cells with offsets of 2 to 3 inches of head pressure of the water. That allows us to constantly reintroduce dissolved oxygen into the system so it never becomes a limiting factor, which is one of the big concerns with a lot of the other systems that are being used right now.
I see. Okay. And so talk about maintenance then. If you're talking about how we often see the larger sites reduce their, over time, their ability to treat reduces significantly. Tell me about your maintenance schedule and how that works with these boxes specifically.
The current maintenance system then is twice a year we come back and we clean the boxes out. Excuse me, the metal removal units. I'll call them boxes at the same time. Apologies. But the idea then being that we come back twice a year on a routine maintenance schedule that's based on your overall loading and flow rate as well as the overall size of the system too. So there's some room to play there. But then we would come back in and either suction the systems out or the boxes out, remove that material, pump that back into one of the holding ponds that already exists on site. And the biggie is that we can always get the system back to fully clean within a very short space of time during that daily or that time of the maintenance schedule. So you get a 100% reset, whereas the larger systems, you're losing some of your treatment volume to the material that accumulates, and your surface area over the long term is removed.
And so you're talking about consistent treatment year-round?
Yes, that's one of the keys. Biologically speaking, and from our results from last year, that manganese was coming out at our one site, pH of 7, and the air temperature got down to negative 22. Now these boxes are buried to the lip. And the manganese oxidizing biofilm that we grow in the box had no issues functioning at 33, 34 degrees Fahrenheit all winter long. We didn't go above TMDLs the entire winter in our effluent. It came in over TMDLs, but we got it all out all winter long, no issues.
So you're talking about a very consistent and measurable treatment?
Absolutely, yeah.
Okay. Year-round, regardless of temperature and
yep.
so on. Okay.
Yeah.
Okay, so here's a good example of a site that we built recently. Colin, do you want to walk us through this example?
Sure. This is in Maryland. Then this system was put in for Arch Coal. It's at a site called Islands Seat. Vindex Energy and CEC were also in on that one as well. And that site then is pulling iron and manganese are the big issues there. It's an 8-box system. And so you can kind of see how we put in multiple units.
Got it. Okay. So, and again, this is really, no matter what the lay of your land or what your site looks like, these can be laid in and organized exactly as you need them and on your existing site footprint in most cases, would you say?
Yeah, we really can shoehorn it into just about anything.
Okay, great. And so just moving on, this is a site we have Bentley. Colin, anything to say to this one?
This actually is the site that went through the winter and pulled manganese biologically pulling manganese when the water was, we took it from 4 feet under the ice. And then you can see the first oxidation step there. And that's the key. If you keep the system well insulated, and basically during the winter, we put lids on, hay bales, and tarps. And that allows us to get that volume that we need, dead airspace. And then as long as the water keeps running and it doesn't stop at any point in time, the system won't freeze up and the bugs will do their thing. The biofilm will do its thing all winter long.
Got it. Okay, so we've already talked a little bit about maintenance. This is a great picture. This is the actual fiber substrate. Colin, could you talk about what's actually going on inside these boxes in as basic a terms as you can? I know it gets pretty scientific, but...
Sure. What we do then is we're creating a wetland effect by providing surface area. What you're looking at is coconut coir covered in aluminum. Coconut coir is shredded up coconut, simple as that, but it's lignin. So unlike cellulose or hemicellulose, say cornstalk or hay that breaks down very quickly, the lignin that is the coconut coir takes years and years and years to break down. So it's close to nature's plastic as we've been able to come for a substrate. And the big thing, it lasts for long periods of time.
Okay, and this is included in the maintenance as far as cleaning this out. This is something you handle completely. They don't have to worry about the box becoming too full or overloaded.
Absolutely. It's one-stop shopping, you could say, that we take care of whatever the issues that should come up within the box. Then that's part of the maintenance agreements. If we have to add more coconut coir, we do that. It's covered.
Like it. Great. Okay. So again, we're going through just a little bit about the boxes and how they work. It depends on who's out there listening. Colin, can you go into why is this, why, without adding any electricity, any heat, any process to this, how is this so effective in a passive way? And what exactly is going on in this box in as simple terms as you can explain it?
Well, and that depends on what the material is that's coming out. Iron and aluminum are adsorbed. They're being caught in the stickiness basically of the biofilm. That's how we get the iron and aluminum out. So you create a wetland, and it's basically just sequestration through adsorption. The manganese, though, that then becomes a biological oxidation from a bunch of different forms of fungi. One way or the other, though, it's still saying that if you have the right mix of fungi within the box, that it will bio-oxidize the manganese within the system and then capture it within the box itself. So depending on what the material is, it depends on the exact process. But while there are differing processes that are happening within the box, they're all happening at exactly the same time. And once again, it's passive. The biofilm that grows in these boxes are ubiquitous to nature. You couldn't keep them out if you wanted to. We build a box, and it's the field of dreams effect. If you build it, they will come. You can't keep them out. And then, so we, as opposed to inoculating with material or bugs from, say, a lab, we just introduce what is already in nature, give it a spot to grow, and it'll do its thing. And then the metals then fall out and are sequestered based off of their reduction oxidation or within a predictable rate and scope, so that the aluminum comes out, then the iron comes out, then the manganese comes out. And you can actually see it in the boxes. It's really interesting because they'll just be inside the individual cells will be different colors of where all the material is falling out.
And so you create a very specific environment, and then you basically get out of the way and let nature take over from there, would you say?
Yes, yeah. Specifically, it's a man-made wetland that is self-selecting of the microbes depending on the material in the influent. If there's a lot of aluminum, you'll select for a different biofilm. If there's more iron, if there's more manganese, you'll select for those other forms of biofilm.
And this isn't something that you're just sort of hoping is going to work, or it's something that's new that may work. As I understand it, for the last how many years now have you had these boxes in the ground with testing going on?
Since late 2011, 2012, we've been running lab certified samples through double blind standards. So I don't hire the person pulling the samples and then they take it to their own specified certified lab because those are their TMDLs. That's what DEP requires of them. So
Okay.
we just go off of the numbers that we've been handed back by the labs.
Okay, this is a good time. Let's get into the sample data here soon. If you can read this, I know my screen's a little bit off. I'm going to try to get the full size back up for you here. There we go. Okay. One more. Okay, so can you walk us through this chart, Colin?
Okay, this then is Albert's site. What we're looking at then is the aluminum numbers. Now, aluminum TMDLs, of course, they are tight, real tight. So this is a 20 gallons a minute. This is a 2-box, 2 MRU system. Can you go back just one slide? That's one of the boxes then. Thank you.
Is this the one or this one?
Yeah, that's it. So what you're looking at there, that's Albert. That was put in 2014, pulling iron and aluminum, and just wanted to show then on that graph that the boxes then will get you to your TMDLs, and we could go even lower than that if we had another box. So if you have a system where you've got an exceptional value trout stream and you're having a hard time with your aluminum, come give us a talk. We're happy to come out and take a look because we can achieve your TMDLs for aluminum.
Okay, let's keep moving here. I know you guys probably have things to do, so we'll just keep chugging along. And this is another photo from Albert's site?
Yes, that's the influent coming in the front end then.
Okay. Explain a little bit about inside of this box. I know it just kind of looks like murky water. What's happening here?
So the water's flowing in. Now, we've actually just flipped the whole system around. What you're looking at is a top-down flow. So the water comes in, and then it percolates down through the wetland that is grown on the biofilm and is collected at a manifold that is at the bottom that then pops back up again. You can see into the second cell, then that pipe coming out of the second cell is actually the collection from the bottom of the first cell. Okay. Now, we've actually flipped that around. This is an older style box. To get much, if we go from bottom up, we get a much better flow profile, less clogging issues, longer times between maintenance, which is a biggie, and just better flow characteristics all around. So this is even an older box. We're beyond this one.
Okay. All right, let's keep moving here. I know we've got a bit more of a detailed graph here. Colin, do you want to explain this in this site?
Yeah. This is one of the ones that I was really the most proud of. This is at Flight 93 Memorial back in 2013. Some of our early prototype boxes, where what you're looking at is that is that manganese? It's kind of high residence. That should be manganese then. Oh no, excuse me, no, it's total iron. So that's iron removal in the box. You can't tell that that's a 2-box system right there, and pretty much showing the consistency of iron removal. Now, iron is mostly just adhesion, so iron's the easy one. But then also you can see that the 0.5 all the way down to 0.1, 0.2, well within your effluent limits. As far as manganese goes, it's important to have your iron down below a 0.35. Our systems work best under 0.35 iron for the manganese to drop out.
So here's a picture from our Glasgow site. What's going on here? I see there's an interesting pattern going on there. Would you say?
Yeah, this is one of our very earliest prototypes as well. I actually made this one out of plywood and epoxy. Now, what you see is a weir type system where the water's coming up and flowing over the weir then, and you're looking at biofilm, long, beautiful strands. In this case, since it's slightly green, some photosynthetic biofilm, but that is what causes the adsorptive or that kind of sticky bonding of the material coming through the system. This very prototype right here, average removal rates for manganese at a system are 2 to 10 grams per meter squared per day, and that came from Dr. Bill Burgos, one of his papers with Penn State. This box right here did 281 grams per meter cubed per day. So we had an exponent of, it was exponentially better than whatever the standard manganese, current manganese alkaline beds exist right now. So that's where we get this density of treatment, because we can be so much smaller because we can treat in such a tiny space better than anything that's out there right now.
Great. And so
based off of our lab certified lab results.
And we can share these with you. We'll give you all the information at the end of this webinar. As we wind down here, you want to be thinking about your questions that you have, and use the chat box in your control panel and enter your questions there, and we'll get that to them in just a minute. So moving on, we have one more chart here to go over with you. Colin, would you like to explain this one? This is the manganese one.
Actually, that was the one I was just talking about. So you can see manganese in, now this is at 5 gallons a minute. This is 2013. Our current systems are running about, per box, about 25 to 30 gallons per minute. So we've increased the size of the boxes as well as the flow rates pretty significantly. But what you see coming in there, in the beginning, when we first started there, you see August 24th, that was day one, brand new, no wetland effect whatsoever, also no manganese removal. Generally takes about a month to a month and a half for the biofilm to entirely grow and become effective within one of our treatment systems. So there is a little bit of a lag time because you are relying on a wetland effect. But then once it gets going, as you can see, I mean, we're going from mid 30s all the way down to 2 manganese.
So it takes a short amount of time for these things to reach a peak efficiency.
But once they've established, you can't get them out. I mean, you'd have to wipe out everything in the box to get them to stop working at that point. So once they're established, once you have your wetland effect within the system, you're golden. They're going to do it all year round.
So it's a very robust system that basically once it starts, it's actually hard to stop.
Yeah, absolutely. Okay. Yeah, you would have to clean out the box and remove all the material entirely to reset the system, which is good because when we go back in and have to do our maintenance, you want to make sure that you don't take out absolutely everything. You have to leave some amount of material, a little amount of material, the manganese dioxide and the biofilm that's in the system in the box, kind of as your mother, as your seed for the next round. So we generally don't clean too. We don't go too crazy when we clean them out because you do want to leave some of that still left in there. That's your reset.
So a simple annual or biannual maintenance package typically works best?
Yes.
Okay, great. Okay, let's keep moving here. Colin, how about this one? This is an interesting photo.
That was also from Glasgow's site, the one that you were, the last two slides. Then that's the manganese dioxide. Now, this was identified by Florence Ling, who was working with the Smithsonian Institute. What we're looking at is diatoms and manganese dioxide. So that's we had to make sure absolutely we knew what we were looking at, and it was in fact manganese dioxide called ranciaite. And that's something that Florence had pulled together for us.
Great.
And again, then this is a picture of the actual coconut coir, the lignin, with the manganese dioxide spalling off of it. So the fungi are releasing this manganese peroxidase that grows directly off of the coconut coir, and then the manganese dioxide is either filling in the spaces in between the interstices between the coir or coming right off the coir itself. And this was another one that Florence had pulled together for us. And then this is Eagle Sight then to demonstrate the temperature range. If you notice there, we're talking January into March. And the removal rates then from their TMDLs all winter long. The spike on 2.5 of 15, that could be an iron issue. I'm not exactly sure what was in there, but I had to leave it in there. That was the results.
Great. And these are the numbers. We'll give you access to the slideshow after this, and you can really pour over these and look through them in detail as you need. For the sake of time, we'll just keep moving along here. Anything you want to say to this one, Colin?
Yeah, the water temperature was about 34 degrees Fahrenheit.
So you're talking about a Pennsylvania and a northeastern winter, so these things are robust enough to handle almost any climate.
Yes.
And to wrap things up, Colin, I know we covered a lot. I'm going to look for questions here. But before we continue, you are a growing company. You have boots on the ground and people in the field every day now. But if you are interested, and this is something you are thinking about that your site or a client site of yours could use, you definitely want to get a hold of Colin soon, as the build schedule does fill up quickly, and we want to make sure we get you in, because it is on a first come first serve basis. So if you want an estimate, you'd like Colin to come out and get a site visit, or most importantly, get on the build schedule so you can get these in the ground and working quickly. That's really important. Let's check and see if we have any questions here, see if we can answer anything for you guys. Do we have anybody in the chat? Nobody at all. Okay, so if you think of any questions, we'll give it another few minutes, Colin. Tell me about what's happened in the last few months at the few sites you've been to. What kind of success stories or case studies have you seen?
Well, we've been learning a lot about aluminum. Has been one of the issues in phosphate binding. So as far as making sure that a system that, say you've got a brand new site, it's still actively being mined. Water's coming straight out. You have no wetlands whatsoever. We've been finding then, depending on what the material coming out, say whether it's aluminum, ways to adapt these metal removal unit systems to a system that is brand new, or a site that's brand new, by knowing, so to speak, how to fertilize it, exactly what we're going to need to do to get that site, that system up and online and running as quickly as possible. Now, there is the caveat: brand new system, they need treatment on day one immediately. Our systems do take about a month and a half to really get going. So that's one of the things that we're trying to overcome by either taking material from our other systems that are currently working and bringing them on site, and then knowing what nutrients to add. Because once again, you're growing a wetland. You have a biological system that is doing the work for you. It's doing it passively. It's doing it for a lot less cost. But like anything that grows, you still got to baby it just a little bit. So you have to keep an eye on your nutrient profiles. But boy, if you have to add a little bit of nitrate or phosphate, that's pretty cheap. Now we're talking that those are lessons learned from agriculture. So the technology is real basic to get some of these systems up and moving.
So from the time somebody would, say, give you a deposit to put a site in, how soon could they actually be seeing some treatment?
2 months. Okay. Say we were handed a check. Build time, if we don't have anything else in the way, we could probably, depending on the size of the system, we can have the units constructed and ready for delivery in about 2 weeks. And then construction goes pretty fast. They're modular. They're like Lego blocks. If the hole that they're going into is already constructed and built, we put them in the ground, bury them up to the lid, get the water running. Month and a half to get the biofilm, the wetland effect fully established, and it's on from there. And then we just monitor and clean out when it's necessary.
Great. And so, you've been doing a lot of research recently about some new and exciting things on the horizon. You want to talk a little bit about that?
Yes, MRU is standard. We call them as metal removal units. Well, we're looking at calling them metalloid removal units as well. And I say that because we're now creating, instead of an oxidative box, one where we introduce oxygen, sealed lid units that allow for reducing conditions, because we're going after sulfate and selenium next. So we've got a couple different sites we're lining up with a couple other big actors to begin research and development on and seeing exactly what is necessary to pull selenium at much reduced cost compared to what's out there right now, and with the same size footprint as well. The boxes are the same. It's the same box, just basically with a lid. So we create a reducing environment.
And so you're saying that, I know this is still it's fast coming, but there's still some research to be done there. As I understand it, you're looking for potential partners that would want to help fuel this process, and it's something you can help them with and maybe partner with them?
Yeah, absolutely. We're offering for the short term here demo contracts, which is then saying that we're looking to do good science, research and development with willing partners to put in these systems and then sample and get them moving forward and this is once again for the reducing boxes, to see what level of scaling is required and get a generalized cost profile to move forward and get boxes in the ground after we really get it refined.
So if you have a site with selenium and sulfate issues, this is something you probably want to contact Cullen about relatively soon. It's a good opportunity, could save you some money, and really bring things forward. Yeah. Okay, great. Well, I don't know, Cullen, is there anything else you wanted to say? It looks like I don't see any open questions here. You got about 2 or 3 minutes to ask them before we end the webinar, maybe get you off to an early lunch. Anybody else? Anything else? Anything else you want to say? Okay. Colin?
No, I think we hit on all the major points. Yeah.
Okay.
Yeah, just thank you very much for joining us today. It was a pleasure to be able to give you this information.
Yeah, thanks a lot, guys. I see you've everybody who's on stuck with us the whole way through. So hopefully that means we've given you some answers to a lot of your questions. If there's anything we didn't answer and you think of it later or what have you, email Colin at the email address on the screen. He'll be more than happy to get back to you quickly. And I'm sure he'd love to come out and visit your site, answer any questions you have. All right, guys. Well, thanks for everything. That concludes this webinar, and we look forward to speaking with you and hearing from you. Have a good one.
Thank you.